All right. Hi there. So today we're going to talk about the topic of binary numbers. Okay. As you're well aware about what is binary, binary is zeros and ones. It is the language of the computer. So they are basically three types of binary numbers. Okay. So we're going to talk about today about signed binary numbers and unsigned binary numbers. Okay, so now let us see what do you mean by signed and unsigned binary numbers. So, okay, so unsigned binary numbers, okay, are the numbers who have a positive sign by default. Let's say, for example, you have a number 2. So you don't have a sign before the number 2. It means that by default, the number 2 has a positive sign. Okay, that is the meaning of an unsigned binary number. Now, coming to the second part, the second type, which is assigned binary numbers. So in here, you have two types, two subtypes. The first one is a positive, and the second one is the negative. Okay, so now to understand this better, let us take an example of a binary number, okay, for number 4, which is 0100, as you can see here on the screen. So here, the bit on the left, which is the furthest bit, okay, for here in this example, it is 0. So this bit is called as the most significant bit, which is MSB. Now, if MSB here is 0, that means it is a positive sign number, okay? If the MSB is 1, that means it is called as the negative sign number, okay? So I repeat again, the bit which is on the furthest side of the whole number is called as MSB, which is the most significant bit, okay? If that bit is 0, it is positive. If that bit is 1, it is negative. To understand this concept a little better, let us just go through this table. Have a look at it for 2 seconds just to understand it better. Okay, so here you have 3 columns. The first column consists of unsigned numbers, as I mentioned, which is the first type of your binary numbers. Okay, so here in general, all of these are positive numbers. And I have taken, in 4-bit notation, okay? It could be 4, it could be 5, it could be 8. It depends upon your requirement. So here I have taken it in 4-bit notation. So 0 is represented like, 0000, and so on. Now, if you look carefully, okay, the second column is the same as the first column. You understand? So by default, if it is a positive sign number, as I said, that means the first digit or the MSB will consist of all the zeros from 0 to 7. Okay, now coming on to the third column, which is the unsigned negative type. Okay, signed negative type. In here, as I said, the first bit, which is the MSB, is all ones. Okay, so it's 1000, it's 1001, and so on. So just always remember this point, which is what? For sign which has, if you want a number which is positive, that means it is always going to be starting with a 0. And then if you want a negative number, or if it is a negative number, the number will start with a 1. All right. So I'm going to stop sharing this. I'm going to share my Jamboard so that you understand a little more. We're going to do a practice for a number. Let's just try to understand it a bit more. Okay, so here it is. So here, let us see how are we going to represent the number 6, not binary number, I'm sorry. It's going to be a decimal number 6, okay? So I'm going to take this and just write down here -6 representation. Just pardon my beautiful handwriting. Okay, so here, -6 representations. I'm going to take the representation in terms of bit 4. Yani, I hope you understand about that. 4-bit notation. So what exactly do you mean by 4-bit notation, right? So the number representation will be what? In terms of 8, right? Then it's going to be in terms of 4. Then what comes next? 2, and then 1, right? Okay. So as you know, the base of binary number is what? It's 2 power n minus 1, isn't it, right? Since it's a 4-bit, that means our n will become what? It will be 2 power 4 minus 1, right? Okay, that is what that comes down to 4 power minus 1, which is like super easy, which is 3. That is what? That is 8, isn't it? Right? Okay, my 8 is super beautiful. Anyways, so now let us write down. So +6, right? So I'm just going to write it here in another font for us to understand better. So +6, okay, is what? +6 here in terms of binary is 0, 1, 1, 0, isn't it? How am I writing that? As you know, 4 plus 2 is 6. So in place of 8, you write down 0. In place of 4, you write down 1. In place of 2, you write down 1. And in place of 1, you write down a 0. Okay, so now if I would like to represent my -6, so how I'm going to do it, so it's -6. Okay, so how is that going to turn out? So this bit here, which bit here? The first bit, MSB here, it's 0, isn't it? Simple, just make it as 1, make it the same, 1, a 1, and then a 0. Okay, that's how it is. I mean, that's so simple, isn't it? Okay, now let us try to understand a little bit more with another number, which is -7. And I'm going to represent -7 in terms of 5-bit this time, 5-bit notation. Okay, so if it is a 5-bit notation, it is what? In terms of base 2, it is 16, 8, 4, 2, and 1, right? So 7 in terms of binary is what? 4 plus 2 plus 1, okay? So what you need to do is that for the place value of 16, you make it as 0. For 8, it is 0. For 4, 2, and 1, it comes down to 1, 1, and 1. Okay? So as you can see, for 4, 2, and 1, okay, this is what? 111. So now if it is -7, okay, so the first MSB becomes 1, and then the following numbers will be the same, which is 0, 1, 1, 1. So that is a simple, very, very simple and easy concept regarding your signed and unsigned bits. Now in the next session, hopefully I will be explaining you the second method of understanding the binary numbers, which is called as the ones and the twos complement. Right? I'll see you later then. Thank you.